Blair?
Yes.
I just have one question. Where did you get the 3 hash from?
Yes, good question. So we have the best response is Q1 equals 9 minus a half Q2. We assert symmetry to say that Q1 equals to Q2. So we get 9 minus a half Q1, right? And when we take this half Q1 over to the right-hand side, if we add a half Q1 to both sides, what we'll get on the left-hand side is 3 halves Q1.
Okay.
So we get 1 1/2 Q1.
Okay, I was multiplying it, that's all right.
Yeah, no, that's not a problem. And then U is equal to 9.
Okay.
And then what we do is we say Q1 is then equal to 9 times 2/3. 1/3 of 9 is 3, so 2/3 of 9 is going to be 6. We get exactly the same answer, right?
Okay.
Okay. Now let's do this. Let's look at. Okay. All right. Let's look at our best response graphs. This is going to give us a sense of like potentially how this equilibrium can come into play. On the horizontal axis, we're going to plot Q1, and on the vertical axis, we're going to plot Q2. So let's look at the best response for firm 2. It's going to be Q2 is equal to 9 minus a half Q1. So when Q1 is equal to 0, what's Q2 going to be? 9. Okay. Now, when Q2 equals 0, what is Q1 going to be? So we have 0 is equal to 9 minus a half Q1. So Q1 is going to be 18, right? Because if we get 9 minus a half times 18, we'll get Q2 being 0. So when Q1 is equal to 18, Q2 is going to be 0. So this here is going to be our best response for firm 2. Does everybody see that?
It's 9. Well,
Yes, this is 9. I'm not going to use any more 9s in this class. Okay, does everybody see this graph here? This is just graphing the best response function for firm 2. Okay, good. Now let's graph the best response function for firm 1. Okay, this is firm 1. So when Q2 is equal to 0, Q1 is going to be equal to 9, right? And so Q2 equal to 0 is going to be here. Q1 equals 9 is going to be here, right? Okay. When Q2 is equal to 18, Q1 is going to be equal to 0. Everyone sees that? So Q2 equals 18, Q1 is going to be equal to 0. So Q1 is equal to 0 here, and Q2 is going to be equal to 18 here. Everyone sees that? You have to be careful when you graph this because everything is like really simple for like the Q2 best response function. But when you graph the Q1 as a function of Q2, you're kind of like going backwards. All right. Everyone sees that? Okay. And this intersection here is going to be which point? 6. So Q2, Q1. Now let's think, what would happen if we started at some quantity Q1 equals to 3, right? This here is the best response function of firm 1. If we started at Q1 equals 3, then let's figure out what's the best response function of Q2. Well, to find the best response function of Q2, we have to draw a vertical line and we go here, right? And so so for Q1 equals 3, the best response of firm 2 is going to be some quantity right here. Does that make sense? Does everybody see that so far? Yeah? Who does not understand this? Okay, good. So firm 1 chooses a quantity of 3, firm 2 chooses this quantity here. But if firm 2 chooses this quantity here, then what's firm 1's best response? To find firm 1's best response, we have to fix firm 2's quantity, and then we have to go to where the best response function for firm 1 is, which is going to be this here, right? So then this is going to be firm 1's best response function, right? But now if firm 1 chooses this quantity here, this quantity here, the question is, what is firm 2 going to choose? Right? Firm 2 is then going to choose this quantity here. Right? And if firm 2 chooses this quantity here, then firm 1 is going to choose that quantity here. And then we're going to go down, 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 there, boom, into here. And you can work the same logic coming from this side here. And so what happens if firm 1 chooses this quantity here? What's firm 2 going to choose? The same is going to choose this quantity here. And that's why this is going to be the natural equilibrium. Any questions on that? Any questions? Okay, so what we're going to do is we will take a 3-minute break. It is now 11:47. We will reconvene at 11:50, and then we will enter the second half of the lecture.